Recording. Share my screen. All right. Today is November 7th, and we're supposed to be covering Lab 8, identification of gram-positive organisms. Please note you should be working on your unknown project, and your infectious disease paper is due this Saturday, November 11th. I think you can turn it in as late as 11:59 p.m. There will be no lab on Thursday of this week. Any questions about any of that? If not, let's begin with Lab 8. I'll get that out of the way. Lab 8, identification of gram-positive organisms. There are gram-positive cocci we're going to talk about, and gram-positive bacilli. Let me see if I can straighten this out. Why is there two of those there? I'm going to guess that was supposed to be up. Yep. And that should be up. And that should be up. I don't know what's going on here. Ah, we had one hidden. Oh, it's throwing it off now. Ah, shoot. Let's go back. There, I got it. All right, sort of. That's missing a dot, but other than that, that's a little better. So gram-positive cocci, we're not really going to look at the different species, but I just wanted to show you some of them. And the gram-positive bacilli, I don't think we're going to talk too much about most of them, but Listeria, I think there's one question about them, and Bacillus and Clostridium we will talk about. There are some video clips in today's lab. There are gram-positive dichotomous key. I imagine there's gram-negative dichotomous key as well. And then the case studies. You need the dichotomous key to figure out your case studies. And let me see how the case studies are organized for this lab. I don't remember off the top of my head. Oop, I'm not in Clark. Yes, no, I'm not. There we go. There's one lab where all the case studies are in separate files. And then there's one lab where all the case studies are in the lab module. And I don't remember which one this is. My computer is a bit slow because it's still making the Zoom file for the lecture. I missed lab 8. Oh, there it is. All right, so in this file, this lab, we have the lab module here, the worksheet there, and then each of these are case studies, a separate file for each case study, and then the dichotomous key down here. You need to open up each of the files to do answer the case studies questions. And I'm sorry about this, but this is the way that the lead instructor sent it to me. And I thought about linking them and putting them all on one page. But if I do that and he makes a change, which he's done before, I'd have to change each of these again. And what he did was I don't know, he changed something like case study 7. And so that was the only thing that needed to be changed. So I decided to keep it as separate files. And to answer this one, you're going to have to go through each of the files. Where are we? Nope, not there. All right, the learning objectives for this lab are: 1, understand the principles and how to interpret the results for the CAMP test, the Bialis-Gulen Auger test, the SF broth test, and the Optogen sensitivity test. And 2, be able to use dichotomous key to solve case studies involving gram-positive bacterial infections. When specimens are received in a microbiology for routine bacterial cultures, they are inoculated on culture media that will facilitate the growth of common pathogens and placed in physical environments that will support their growth, usually an incubator. Microbiologists use colony morphology and gram stain to provide important initial information in the primary classification of a bacterial isolate. However, further biochemical testing is required. In this lab, the CAMP test, the Bialis-Gulen hydrolysis test, the SF broth test, and the Optogen sensitivity test will be discussed. CAMP is an acronym of the 3 microbiologists who discovered the test: Christie, Atkins, and Munch-Peterson, who first described the amplified hemolytic effect that some beta hemolytic organisms have when they're physically grown near Staphylococcus aureus. What you do on this test, the CAMP test, is you get a blood agar plate and you make a single streak of Staphylococcus aureus down the plate this way. And then you place your test organism perpendicular to the Staphylococcus aureus. So you streak it this way. You can see 3 different CAMP results shown here. Streptococcus pyogenes is a beta hemolytic organism, and so is Staphylococcus aureus. Let me blow this up for you. So there's the streak of Staphylococcus aureus, and then the white around it is the beta hemolysis of Staphylococcus aureus. I can't get this to expand that way. It's not terribly obvious that Streptococcus pyogenes is beta hemolytic. And if I can blow it up really, really high, you'll actually be able to see it. There. See that single skinny streak there? Streptococcus pyogenes is very small colonies and makes a very thin streak. That is the streak of the Streptococcus pyogenes. And then the whitish region or lighter region around it is the beta hemolysis caused by Streptococcus pyogenes. Any question about that? Let me shrink this down now a little bit. As you can see, Streptococcus pyogenes does not have enhanced hemolysis when it grows near Staphylococcus aureus. For Listeria, when it grows near Staphylococcus aureus, we can see slight or partial enhancement of the beta hemolysis around Staphylococcus aureus. And to see that best, you really do need to blow it up. So let me see if I can blow it up. So right there is the streak of the Listeria. And as you can see, it has beta hemolysis. Let me blow it up even further. Right there around it. And right there we see enhanced beta hemolysis near the Staphylococcus aureus. Any question about that? I'm coming to the third one. If I can do this. I can't get over there now. Nope, that's not what I wanted. I got it blown up so much I can't get to the arrow. Oh, there we go. And then Streptococcus agalactiaceae has greatly enhanced hemolysis in this region where it's grown near the Staphylococcus aureus. Right there, you can see the streak of Streptococcus, and there's the beta hemolysis around it. And right there is the greatly enhanced hemolysis. Any question about the CAMP test? The bile-esculin hydrolysis test uses bile-esculin in an agar, and you inoculate it. And if the bacteria can digest the esculin, it makes glucose and esculatin. Esculatin is a very dark brown color, so it actually looks kind of blackish. So dark brown or blackish color is positive for the bile-esculin. And Enterococcus species are positive for bile-esculin. Streptococcus species are negative. And why does that show it that way? It just does. Maybe it's because I've got it blown up so much. Yeah. It's just that should be moved over a little bit. Nope, that's too small. Let's see if I can move that over. Now I lost it. Ah! That's a little better. All right, any question on the bile-esculin test? Looking to see if the bacteria can digest esculin. The SF broth test is looking to see if the bacteria can ferment the ingredients and change the color from a purple color to a yellowish color. The SF broth test contains sodium azide and a carbohydrate glucose. And if the bacteria can ferment glucose, it will change the pH to acidic, and that'll change the color from purple to yellow. The SF broth test is named after Streptococcus faecalis, which has now been renamed in a different family. It is no longer in Streptococcus faecalis. It's called Enterococcus faecalis, but we still call it the Streptococcus faecalis broth test, and most often just the SF broth test. Any question about that? No questions, so everyone's good on that? All right. Streptococcus faecalis is positive. Which is actually no longer called Streptococcus faecalis. It's called Enterococcus faecalis, which is positive for the SF broth test. Other members of the family Streptococcus are negative for the broth test. Any question about any of that? See if I can move that over a little. Let's go there. All right. The Optogen sensitivity test is testing to see if the bacteria is sensitive to Optogen, an antibiotic. Streptococcus pneumonia is sensitive to Optogen, and Streptococcus pneumoniae is an alpha hemolytic streptococci. If we're trying to distinguish between the different Streptococcus members of the Streptococcus family, we can use the Optogen sensitivity test, and if it is sensitive, then it is Streptococcus pneumonia. If it is a Streptococcus, which is hemolytic, if it's a Streptococcus which is alpha hemolytic and is not sensitive to Optogen, then it is another member of the family of Streptococcus, which is alpha hemolytic. Any question about any of that? So you do not use this test if you have beta hemolysis or gamma hemolysis of the Streptococcus. You have to narrow it down to the family of Streptococcus and then look at the hemolysis. And if you want to separate out the alpha hemolytic bacteria, you can use the Optogen sensitivity test. If it is resistant to Streptococcus, to Optogen, then it is not Streptococcus pneumonia, it's some other alpha hemolytic Streptococcus. What you do is you take the bacteria, and that shows alpha hemolysis. Let me blow that up for you. Oh, that's the wrong way. That's good enough. Yeah, I gotta blow it up further, so I thought that'd be good enough. So there you can see the white colony of bacteria, and there's darkening around the white. The darkening is from alpha hemolysis. Take the bacteria, streak it out in this region of the plate, put on the Optogen, and then incubate it. And if there's no sensitivity, then it is not sensitive to Optogen and it's not Streptococcus pneumoniae. If, on the other hand, it is sensitive to Optogen, and the sensitivity has to be greater than or equal to 14 millimeters, or it's not sensitive, but if it's greater than equal to 14 millimeters in the zone of inhibition, then it is Streptococcus pneumoniae. Remember, the resistant can be no zone of inhibition, but it can be a zone of inhibition less than or equal to 14, well, actually less than 14 millimeters. Any question about any of that? All right. So microbiologists frequently use a dichotomous key that describes which test should be performed. If you want to illustrate how to arrive at a logical solution using the methodical thought process of dichotomous logic, we have a dichotomous key in this lab for you to use. Do not use this dichotomous key for your unknown project. Only use this dichotomous key for this lab, and do not use any other dichotomous key for this lab. So first we can take our bacteria and do the gram stain. If it's gram positive, it goes this way, and if it's gram negative, it goes that way. It's gram positive, so I'm going to cross this out. And then we can do another test which separates the gram positive bacteria into the bacteria based on their shape, which is also dichotomous. There's gram-positive bacillus and gram-positive cocci. So we look at the bacteria shape. It's not gram-positive bacillus, so we cross that one out. We then follow the gram-positive cocci. And one test we can do is the catalase test. So the gram-positive cocci can be catalase positive or catalase negative. If it's catalase positive, it's Staphylococcus. If it's catalase negative, it's either family Streptococcus or Enterococcus. In this case, we're going to scratch out the gram-positive cocci that are catalase negative and follow the ones that are catalase positive. Of the Staphylococcus, we can then run the coagulase test. If it's coagulase positive, it's Staphylococcus aureus. If it's coagulase negative, it's some other Staphylococcus species. We can then run the novobiocin test, and that will separate the coagulase negative species into Staph epidermidis, which is novobiocin positive, from the Staphylococcus saprophyticus species, which is novobiocin negative. Any question about any of that? Anyways, that's doing a dichotomous key where we run a test separating the possibilities by 2, and then just keep going on with that test. All right, you're not physically going to be performing any of these activities, but you will be held responsible for knowing how to perform and interpret them. View the following video clips on the SF broth and the bile esculin test, as well as on the CAMP test. And then review how to interpret the following tests by completing this chart. Many of these tests are in this lab module, like the CAMP test, the bile esculin test, the SF broth test, the optogen sensitivity test, but some of them you'll have to refer to a previous lab to fill in the information. The first has been done for you. We've filled in what the positive result for the gram stain is, for both cocci and bacilli. It's going to be purple, and for the gram negative result, it will be pink. So fill in the table the same as we've done for you. And do that for each of these different tests. Any question about any of that? You can view the video on how to develop and use a dichotomous key. I suggest you do that unless you're very familiar with and you're very comfortable with using a dichotomous key. You must use dichotomous logic in your unknown project. If you're very comfortable, you can skip viewing that. All right, please open the file, dichotomous key, and note that that key has 2 pages in the file. Let me go do that now. Hopefully I can click on that. So the first key is going through the gram-positive gram stain for the conchi, and not really for the bacilli. And you're going to have to blow this up. Let me see if I can get this another way. That'll show it better. So gram-positive conchi set into conchi, catalase positive, catalase negative. Be careful about this. Where is it that people get confused? Right here. It's not telling you what alpha, beta, and gamma is. So I'm going to tell you, this is looking at hemolysis. So the growth was grown on a blood agar plate, and then they looked at hemolysis. If it's alpha hemolysis, that separates it down into Streptococcus pneumonia and Viridian Streptococcus. If it's beta hemolysis, that splits it down into Streptococcus pyogenes and Streptococcus agalactiae. And if it's Streptococcus gamma, it separates it down into Enterococcus and Streptococcus. And then you can split each of those further. I'm just going to talk about gamma. You can separate this one by running the bile-esculin test and the SF broth test. If they're both positive, it's Enterococcus faecalis. If they're both negative, it's gamma streptococcus. Okay, I'm not going to go through all the rest of the key, but let me go to page 2 of the key. This is looking at the gram stain. So it's gram positive, and then looking at the shape, bacilli, and then separating into anaerobes and aerobes. If it's an anaerobe, it's a Clostridium species. If it's an aerobe, it's either Bacillus, Listeria, or Corynebacterium families. And then we can separate the Listeria from the Corynebacterium by looking at hemolysis. If there's beta hemolysis versus gamma hemolysis, Corynebacterium is gamma hemolysis, Listeria, especially Listeria monocytogenes, is beta hemolysis. And I don't know if they do the CAMP test. Listeria is also weakly CAMP positive, meaning partially CAMP positive. Any question about any of that? You use that Gauchonomus key to run the case studies. I'm not going to go through each of them, but I will begin it. Let's go to the worksheet. So there's the table you have to fill out. And then these tell you the different possibilities. And then write the answers here. For case study 1, identify the species right here. Oops, right there. For case study 2, put it in right there. Let's look at only case study 1 and case study 2. I want to talk about case study 2 and maybe a little bit of 3. You can get these online, opening it up, each file. Case study 1, a 13-year-old teenager attended a week-long summer scout camp, and there he is there. Upon returning home, his mother notices pustule beginning to develop in a spider bite. The area is warm to the touch and is becoming extremely painful. When her son starts running a fever, she takes him to the walk-in clinic. The physician orders a gram stain of the exudate and a routine culture. Here are the findings. That's the gram stain. Let me blow this up. How do I do that here? Most of the cells you're seeing here are actually his. All the big pink cells are his cells. These are the cells of the bacteria. And if you blow it up really large, you can find out what the shape of the bacteria is. Right now, we're only looking at what the gram stain is. So you should be able to determine that just by looking there. I thought I shrunk that. Let's go down. And then there's the bacteria when they grew it on a blood agar plate, and you can see the hemolysis on the BAP for blood agar plate. So you should see the gram stain. You can actually see whether it's cocci or bacilli also. And then the hemolytic activity. Go to page 2. They're then taking this bacteria and running the Cadlase test, putting hydrogen peroxide on, and there's the result. Any question about any of that? They then go further and they're putting plasma here, and there's the result there of the test. And then they do another test, and they took this bacteria and they grew it on mannitol salt agar. And for this one, you may need to look in the unknown project, because I don't think this lab talks about mannitol salt agar. And I'm not sure another lab has, although I've talked about it either in the lecture or the lab. Mannitol salt agar only grows bacteria that can tolerate 7% sodium chloride. And obviously this one can. And then you can see that it did something with the mannitol, changing the color here. And that just helps you determine what the mannitol salt agar plate is used for. Any question about any of that? And then answer what bacteria was isolated. All right, let's go on to case study 2. Oh, that's why I don't want to do that. Oh, you can use this for figuring out what the sample is, by the way. Use the dichotomous key for determining what is infecting the boy. Let's go to case study 2. Why I want to talk about case study 2 is it's not entirely clear what is going on. A 27-year-old female is receiving prenatal care, and her OB-GYN physician orders a routine culture of her vagina just to see if everything's okay. And when they did that, they streaked it out on a blood agar plate, and you can see the beta hemolysis here. Oops, wasn't supposed to tell you that. You can see hemolysis here, and there's the gram stain. You can blow it up to determine what that is. And then they do the hydrogen peroxide on the cells here, and there's the result. You can blow that up to see that better for whether it's positive or negative. There, they can tell there. And then they did a few other tests. This one you probably recognize as the CAMP test. So there's the streak of it here, and there's the Staphylococcus aureus, and there you can see the reaction of the CAMP test there. And then right here they have a test, and it's not clear what that test is. When they ask what bacteria was isolated, I have told you on the worksheet what that test is that they're running there. That's the bacitracin sensitivity test. And take a look at that and determine, is it sensitive to bacitracin or not? Any question about case study 2? If not, let me briefly look at case study 3. Close that if I can. There we go. Use this key to answer what the specimen is. On case study 3, the test, which is unnamed, is also the basic trace and sensitivity test. I'm not going to read through it this time. I'm just going to go through the different tests. Somebody has a wound. They do the Gram stain. There it is there. That's very blurry picture, but if you blow it up, you can sort of make it out. Whoop, too far. There I can make out what that is. Let's see if I can come on over here. There I can see the colonies very well. There's a colony. This is a blood agar plate, and that is showing you some sort of hemolytic activity going on. So determine what hemolysis that is. And I might shrink this down now. Oh, come on. They're putting on hydrogen peroxide to that bacteria. There's the result of that test. And then there's the basic trace and sensitivity test. This bacteria is sensitive to it. I guess I shouldn't have told you that. And then there's the CAMP test. So get your results there and then answer what bacteria was isolated and put your answer in the worksheet. So work through the case studies. If you want, I'll be here until 8 o'clock or the last student leaves to help you work on the lab. Any questions about any of that? If not, go ahead and work on the lab. And I will be here until 8 o'clock or the last student leaves.